Okay, let's think about how we would make this product, and let's think about how we would make it from the reactant. First thing I want to do is I'm going to count my carbons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I know that I don't need to add and I don't need to remove carbons. So I'm only thinking about functional group transformations. Okay, so let's think backwards. So what do I have as far as functional group is concerned? I've got an alkene, a double bond. Okay, well, if I have a double bond, how do I make double bonds? If I make double bonds, I do elimination. Okay, well, where would the thing have been if I were doing an elimination? Well, there's some options here, right? I could have had something here, or I could have had something there. Those are really the only two options for elimination. So if I had something in the let's call it the red location, and I'm going to actually go ahead and draw this possible pathway, I could have had a leaving group right here. And yeah, if I use a small base like methoxide, like let's use some sodium methoxide. Let me make that a little prettier. Then I certainly would get the product that I'm looking for from this reaction. The problem is that once I've got here, how do I get this bromine here? Well, we only know one reaction, or we know how to get bromines, a single bromine on a molecule, and that's through hydrohalogenation. That means the double bond was either there or the double bond was there. Well, I don't want to think about the yellow double bond because that's just where I came from. That's going around in the circle. So I avoid that consideration. Well, what about the red one? Well, if I wanted to consider the red location, then I would have a double bond like this. Okay, now that I have a double bond like that, how can I make double bonds? Well, again, we're talking about elimination. Now we're going to see why that initial selection of the red location for the leaving group was going to be a bad choice. Sometimes you have to go back and see. Okay, well, if I had a double bond here, well, then where did I eliminate from? Well, I could have eliminated there, but we already know that's not the place to think about because that's where we just came from. So we're going around in a circle. We don't want to think about that spot. Well, I could eliminate there. Okay, here's the problem. If I had something in that location, this is where I've got some trouble. If I did an elimination from that location, I would actually come up with more than one product. I would have a double bond here, and I would have a double bond here. And this idea that, okay, well, now we're starting to get into a very inefficient reaction where we'd have to throw away half the product. This is what indicates to us that we didn't go in the right direction. The other thing is that we also seem to be doing the kind of the same thing. We're just moving this double bond around the circle, and there's probably a more efficient way to do this. And so let's go all the way back to Jump Street and let's think about this yellow location. So I could have had a double bond in that yellow, or excuse me, I could have had a leaving group in that yellow location. I would still just do some sort of methoxide or something like that in order to get the Zaitsev product. So the question is okay, well, how would I put a bromine at that location? Well, now that the bromine is in a tertiary location, now I've got more options. Sure, I could still have done hydrohalogenation, and I could have had a couple of options. I could have a double bond here, or I could have had a double bond there. And keep in mind, the two yellow locations are identical. The yellow is just going back to where we started, so that's not the way to think about it. So what about red? Okay, well, I'm still getting into this situation where if I think about this and I go back to that spot like this, 1, 2, 3, 4, 5, 6, and I had a double bond here, then we're going to have some of the same considerations as before. Well, I could have eliminated something at the yellow position. That would get me back to where I was. That's a circle. We don't want to think about that. Well, what about the red position? Okay, I could have eliminated something from there, but once we get there, we'll find out that we're stuck. We can't get any further. And so what actually the path that we actually want to think about is here, because hydrohalogenation is certainly an option, but so is radical bromination. Once we got a bromine in a tertiary position, I can directly make a hydroalkane from an alkane with radical halogenation. And so I figured it out. I've got the whole path. So step one was Br2 and H nu. Step two was methoxide, CH3O and A. Okay, that's it.